Good morning children, I am Saradisis. Now I am going to teach you sex determination mechanism. Sex determination means finalization of sex of an organism at the time of zygote formation. So the sex is determined by the sex chromosomes. So we can say the chromosomes which can determine the sex of an organism is called sex chromosomes. As you know, chromosomes are of two types. So the chromosomes are two types. They are sex chromosomes. Sex chromosomes are also known as allosomes. Allosomes. And the second type is autosomes. Here, the sex chromosomes determine the sex of an organism and autosomes determine all other somatic characteristics of an organism. Is it clear? So, these are the two types of chromosomes in the organisms. So, here, the determination of sex mechanism is of two types. Let's see which are the two types of sex determination mechanism. So here, the two types of sex determination mechanism are male heterogamety and female heterogamety. Male heterogamety means males are producing two different types of gametes or two dissimilar gametes. Is it clear? For example, XY. XY means two dissimilar gametes are produced by the male. Is it clear? And here also two different types of gametes are produced by female. So male heterogamety means when the males are producing two dissimilar gametes, that is called male heterogamety. When the females are producing two dissimilar gametes, that is called the female heterogamety. As you know, in human beings we can see male heterogamety. Am I right? And the females are having similar gametes, XX. And XY or male heterogamety is XY in human beings. Let's see the different types of male heterogamety or different sex determination mechanism based on male heterogamety. Okay. So here we can see the male heterogamety. Two types of male heterogamety we can see. The first one is XX, XY type. And the second one is XX, X0 type. Okay, here XX, XY type, these are coming under male heterogamety. That means the male is producing dissimilar gametes. Then can you identify which is the male gamete here? This is a homozygous, so it is female. So this is the heterozygous, so this is the male. Am I right? So this is the male and this is the female. Why? So male is showing heterogamety. So this must be the male genotype. Am I right? So XY is the male and XX is the female. Here also we can see which is the male. Which gametes are produced by male? Here. So here only one gamete is produced and there is zero gamete. In the next gamete there is no sex chromosome, that is why X0 type. Here due to this homozygosity, this must be the female and this is the male. Is it clear? So these are the two types of male heterogamety. Which are the two types of male heterogamety? XX, XY type and XX, X0 type. And now we can see this XX, XY type. XX, XY type can be seen in human beings, humans and Drosophila melanogaster. Drosophila melanogaster, you are familiar with Drosophila Drosophila melanogaster. These fruit fly. These are the Drosophila melanogaster. And in Drosophila melanogaster and human beings, we can see this XX, SY type of sex determination. Okay. Now we can see what are the possibilities of this XX, XY type. In XX, XY type, which is a gamete produced by this female, X gamete is produced. And here also two types of gametes are produced, X and Y. So this X can cross with this one, so XX, and this X with this Y, then XY. So this is the female child and this is the male child. So this X is coming from the male and this Y is coming from the male. So here the sex of the child is determined by male. Is it clear? That means the sex of the child is determined by the parent who is having heterogametes. So which parent is having heterogamete here? Male parent. Is it clear? Due to the heterozygosity of the male parent, he can determine the sex of the offspring. Is it clear? So this is the XX, XY type of sex determination commonly seen in Drosophila melanogaster and human beings. Is it clear? Next we can see XX, X0 type. And this XX, X0 type here, as I told you, this is the female parent and this is the male parent. In this we can see this XX, XY type of sex determination we can see in grasshopper. Example, grasshopper. Okay, in grasshopper we can see XX, X0 type of sex determination under male heterogamety. We can see the cross. So here X type and X and without sex chromosome. So two types of gametes are producing. Here also we can write two types. So only one gamete is there. Egg, they are producing only one egg. Here they are producing gametes with the, one is with the X gamete and one is without sex chromosome. Is it clear? And when it is crossed with the XX, so here and another chance is this one. So here the child is female, here the child is male because this is the male character and this is the female phenotype. Is it clear? And here the offspring, the sex of the offspring is determined by one of the parents who is having heterogamete. The homozygous parent do not determine the sex of the child or sex of the offspring. Only heterogamete, heterogamitic parent can determine the sex of the child. Here the heterogamety is carried by male parent. So here the parent who is having heterogamety only can determine the sex of the offspring. Is it clear? So these are the examples for male heterogamety. The first XX, XY type is common in human beings and Drosophila, and XX, X0 type is common in grasshopper. So the types of male heterogamety are XX, XY type and XX, X0 type. Is it clear? Next we can see the female heterogamety. Here we can see female heterogamety. Here normally we want to give two dissimilar gametes to female. Then only the female heterogamety happens here. But if we are giving XY, we need to give dissimilar gametes. So how can we give XY? So it causes confusion. So to avoid confusion, for X we can give another letter Z. For Y we can give another letter W. Is it clear? So we can see which are the two types of female heterogamety. EZ, ZW type. That means it is equal to XX, XY. Okay. Here another type is Z0 type. Okay, Z0 type. Here, so normally female need to be having heterogamity. So which is the female parent here? This is the female parent, right? So due to homozygosity, this is the male parent. Okay, so here which is the female gamete or female parent? This is the female and this is the male. Is it clear? So here we are considering the female heterogamety. So the female must have heterogametes. So the homozygous or homogamete is carried by the male. Is it clear? Now we can see what are the possibilities. So here is a gamete and two types of gametes are produced by female, and when we cross ZW, and this is male and this is female. So here also the sex of the offspring is determined by the parent who is having heterozygosity. Which parent is having heterozygosity here? Female parent is having heterozygosity here. So the female is determining the sex of the offspring here. Is it clear? This is the female heterogamety, and this type of ZW sex determination mechanism is common in birds, most of the butterflies, then fish, etc. So this ZW or female heterogamety is common in birds, most of the butterflies. Some butterflies are showing this type of gamety, this type of sex determination, and fish also showing ZW type of sex determination. Clear? Now we can see this type. Here, so example, birds, you should write this. Then we can see here which is female, this is female because they are possessing the heterogamety. So here this is the gamete. Here two types of gametes with the sex chromosome and without sex chromosome. And when we cross Z0. So Z is the male and Z0 is the female. Okay. So here also the sex of the offspring is determined by the parent who is having heterozygosity. So the female parent is having heterozygosity and the female parent is determining the sex of the offspring. This is called a female heterogamety. And example, here also we can write example. Okay, so here we can write example, some butterflies, most of the butterflies are showing ZW, but some butterflies are showing Z0 type, and moth, cockroach, etc. Is it clear? Now we can see next area, a peculiar case of sex determination mechanism in honeybee. So in honeybee, how the sex is determined. And in honeybee, you already learned honeybees are undergoing parthenogenesis to form male bees. So here the honeybees are producing two types of eggs. First one is unfertilized egg, and second one is fertilized egg. So here this unfertilized egg undergo parthenogenesis to form male bees, and these male bees are called drone. So undergo parthenogenesis So drones are male bees produced by the parthenogenetic process of unfertilized egg. So the unfertilized egg undergo parthenogenesis to form male bees and they are called drones. Okay. Now the next fertilized eggs are forming two types of bees. First is queens, and second one is sterile female. So queens and sterile female, they are acting as workers. So they are not capable of fertilization. They are sterile female. They are acting as only workers, and they are queens produced by the fusion of male and female gametes. So this is the sex determination mechanism in case of honeybee. Is it clear about sex determination mechanism in various organisms? Okay, that's all for today.